Imagine a Cubesat designed in two places at once, on the factory floor and inside an intelligent metaverse laboratory. AI and digital twins connect manufacturing, engineering, testing, and mission control into one continuous workflow. During manufacturing, computer vision checks components for defects and verifies tolerances. AI guides technicians through precise assembly and learns from every build, helping teams improve quality before a problem reaches the flight unit. In the metaverse, engineers can explore a full-scale digital twin from anywhere. They can rearrange the structure, power system, communications, avionics, and payload, then compare mass, thermal behavior, energy use, and risk before ordering hardware. The virtual spacecraft can be tested against vibration, temperature extremes, radiation, and deployment events. Operators can also rehearse normal and emergency procedures with an AI coach without putting a real mission at risk. As the physical prototype matures, sensor data updates the twin, creating a living record of how the spacecraft behaves. In orbit, AI helps forecast power, prioritize payload operations, optimize communication windows, and detect unusual telemetry. Operators can test commands on the twin, check constraints, and approve safe sequences before sending them through the ground network. When an anomaly appears, AI ranks likely causes and response options, while the human flight controller makes the final decision. Every mission then improves the next one. AI provides insight. The metaverse provides shared context. Cubesats provide the proving ground for faster, safer, and more confident space innovation.